Okay, this session I'm working on SimpleArchiver. This time I'm not editing existing code for this particular session because I'm making something new. This time I'm making a new data structure, which is, well, relatively new. Like, for this project is new. Kind of. Well, it's basically another hash map. I already have a hash map implementation, but I'm adding another hash map that is string keyed. And because it is string keyed, I can optimize it for that specific use case. So I'm basically just making a hash map that is designed around having strings for keys. So as you notice, the original hash map used the linked list as a bucket. But for my use case, I need more control over what data goes into a node, or a bucket, in this case. So I'm modifying when I'm implementing this new hash map, I'm making sure to use a node type of my own. By using typedef struct and then struct name and then open bracket close bracket or curly brace close curly brace and then the name again, it works like this. The struct and then name defines a type, that is, you define it in C as struct and then the name. The typedef also assigns the name at the end the type of the struct type name. So by using a typedef struct name, open curly brace definition, close curly brace name, and then semicolon, I'm able to refer within the struct as itself by using the struct name, and outside of the struct I can refer it by just the name that is noted at the end of the definition of the typedef. So long story short, C structs can be self-referential if needed. So notice that I do not have a variable set for a string inside the node. That is because I'm going to store the string alongside the node's data, just like I did for string list. So I malloc the node and, well, when the node is allocated, it's not just size of the node, but it's the size of the node plus the string plus 1 for the null terminator. And the node's data ends with the string. So if you take a look at the node data inside the hash map using string keys, well, it does the offset of the node size. It uses an offset of the node size just to get to the string itself. I do recall that there's some usage of variable length structs in old C code. So this way of doing things is a bit different than that because there's no reference to the string being passed in. It's literally just take the pointer, make sure you index by character so it does it by byte, not by struct, and then use that offset, and then that's basically the string inside the allocated memory. Thinking about it now, you probably might be able to get away with not converting the pointer to a character pointer, because if you just do the node struct pointer plus 1, it's technically the same offset. Thinking about it now, that makes sense. I purposely make the implementation, the known functions for this new hash map, this almost the same functionality as the previous hash map, because, well, it's easier that way, long story short. I'm reinventing the wheel again, but at least I have an existing hash map of my own to reference by. So the header file is basically done. Now I just need to implement it. Checking the hash maps code. to make sure I'm doing things sane, not insane. So I'm doing size of void pointer because every pointer is the same size on the same machine. For example, it's a 64-bit machine. 64 bits refers to the pointer size, which is 8 bytes. So on this machine, every pointer is 8 bytes. Doesn't matter if it's a pointer to a struct or a pointer to void, the size of that pointer will always be 8 bytes on this machine. The way I designed this string hash map, string keyed hash map, I have the first entry in the bucket like a sentinel value. The values for bucket start after the first one. So that's how that one works. Notice that the nodes are used in a singly linked list manner. If there's ever a memory issue with this cleanup function, I'll be revisiting this particular one. I can test for it using unit tests and Valgrind later on. So I think I was a little bit worried about changing the hash function to accept strings, but to maintain compatibility with the previous hash map, I decided to keep the function signature the same as it was before. So it still just accepts a pointer and a size for that pointer, instead of a C string. Though I only use C strings in this particular hash map implementation. To put it simply, keeping it generic makes it more usable in other cases. So I keep the bucket size odd mainly because whenever I'm indexing into a bucket from a hash, well, if it's an odd number, chances are it'll, well, modulus more cleanly than a even number. For example, you have the choice between bucket size of 16 or 17. If you do 16, well, the number you get is heavily based on the hash being a certain value. If the range of the hash number is low, then there might be repeats that are more common than using a hash size, a bucket size of like 17, which happens to be a prime number, I think. Long story short, I have the opinion that having an odd bucket size is better for indexing, for hash indexing, but it might not be completely necessary. I think something like that probably requires testing, to be sure. Long story short, again, me making the bucket size odd is a gut feeling kind of choice I made. If you work with random number generators a lot, well, you may be pleased to know that the hash function is basically a modified version of a random number generator. It does the job. I don't need it to be cryptographically secure or anything like that. I just need to hash strings to fit into an evenly distributed amount of buckets. So a random number generator is decent enough for my use case, I believe. So rehashing is necessary for hash maps because you start with a you start with a known number of buckets to hold items in, and eventually you run out of room to the point where you may be overburdened with too many items in a bucket, even if you've balanced it well with a good hash function. The fix is to make a new map with more buckets, and then put all the buckets data from the old map into the new map, and then replace the old map with the new map. That's basically what rehashing is, what this rehash function is doing. Basically, just handling the case of when a hash map is running out of space. Not that it actually runs out of space, but if there were more items in a bucket, it takes longer to find a particular item you're looking for. As long as the items are evenly distributed among all buckets, and as long as there isn't too many items in one bucket, the amortized runtime should be basically close to constant time because of the hashing part. Worst case constant as long as that is guaranteed. Pointer handling gets tricky even here. I need to rehash a map with a single pointer, not a double pointer variable. So this implementation currently isn't correct. If you have to deal with pointers, this is one of the kinds of things you would benefit from knowing. I do fix it by the end of this session, so keep an eye out for that one. And this is where I allocate enough room for the struct and the string key. Notice the node is malloced with the size of the node and enough room for the string. The final thing I do here is use a mem copy to copy the string into the data. I cast a pointer to a character and then sum it with the size of the node in bytes so that I get a byte offset. And that offset is where the string lives. This only works for strings, C strings, and not structs. I don't think it would work for a arbitrary struct because C strings don't require alignment because it's a byte array, but structs require alignment. And if you wanted to combine two structs together in this manner, you would have to also keep track of alignment, and that can get pretty dicey. So since this is a singly linked list, removals of a node require having a reference to the previous node. Otherwise, you would lose your place once you remove it. So now I'm moving on to writing the unit tests for this. Naturally, you should expect things to have been not correctly implemented until all the unit tests pass. Didn't update CMake's file for this, so I'm adding the entry for the string list or string keyed hash map. So freeing an empty hash map, there is no next bucket after the first node in the bucket. So I need to add checks to make sure that it doesn't try to dereference a null pointer, or try to get next through a null pointer, that is. Memory leak, oh boy. So Valgrind only tells you where in the code the memory that was leaked was allocated. Naturally, it wouldn't know of any code that would have freed it because it never got freed. So if I'm passing a string literal to the hash map, I can't free that string literal because it lives in program data and it is loaded into RAM once the program starts. If I had instead put in allocated buffer by using string duplicate here, then it makes sense to free it. It's kind of like those string constants in Rust. You know, the static reference character, and that same similarity. Any string literal should never be freed in C. This time a null function pointer dereference. Kind of odd that when things are working, the output of the unit test is very sparse. But that's just how it goes, I guess. since the numbers keeping track of successful and total checks are static and atomic variables, I can use the check true macro here in a separate function. So at this point, it seems strange that everything seems to be working fine. That is only because rehashing hasn't really occurred yet. Since the default initial size is 32 buckets, which is actually 33 because it's always like the number and then plus 1. So I need to actually force a case where there are more than 32 items being pushed into the hash map. Otherwise, not all the code paths for the new data structure would be tested with the unit test. Not that I'm doing code coverage, but you really do want to cover as much code as possible with your unit tests. Luckily, the compiler caught the error that I made, that I reduced the size of the buffer to 16, and then passed 64 to printf. And this is where things are strange. I forced it to rehash, but nothing happened. Other than it seemed that it succeeded. Problem was I didn't increment the count, and rehashing checks the count before rehashing. I also didn't decrement the count when removing as well. So, yeah. Right now, the current implementation is rehash if inserting and the count is the same amount as the number of buckets. And the rehash is approximately 2 times the previous value. Or approximately 2 times more buckets. Approximately. And now we see problems, which I kind of expected. Something like this can't really be done one way through. You can't really first try a data structure. So this is what I asked to look out for. I'm addressing it now. It's a single pointer to map. So what I do is I set dereference the pointer, dereference the new map, set the dereference new map to the new dereference new map, and then free the new map. It keeps the previous pointer from being freed, and it doesn't mess with the previous pointer as well, other than setting the new values set in the new map. So I'm checking for how to fix this memory leak that's left. Kind of think maybe I didn't free the first bucket. Actually, it's a bit worse than that, but it's really the first of every bucket that has to be freed that wasn't freed in rehash. So I eventually get that done. That's just the tricky thing about memory leaks and memcheck. Memcheck can only tell you when the memory was allocated, and you have to work forwards from there. Yeah, it took a while to figure this one out, but I do eventually fix it. And at long last, I've fixed all the memory leaks. I should have covered most of the code path of all these functions, including rehashing. I actually forget to check the count value in the map in this unit test, but I add that later, and it turns out the count was okay the entire time. So yeah. Have a grep command to check if any line is greater than 81 is at least 81 characters long to enforce the 80 character limit. There's a history with that. Something like long time ago, computer punch cards were 80 columns wide. And I think it's been that way since, 80 columns being significant. It's an interesting thing. Anyways, that's basically it. I just commit the changes and push at this point. So thanks for watching.